Welcome back. In this section we are going to work on two questions. That is question 8 from Differential Calculus, that is differentiation, and then I'll combine it also with question 9 from the DBE 2022 question paper. So get straight into the question here. It reads 8.1, determine the derivative from first principles if it is given that f of x is equal to negative x squared. So we are given f of x 8.1, f of x, which is our function, is equal to negative x squared. So we know that the equation, the formula that we use for the derivative from first principles is the derivative of f of x is equal to the limit as h approaches 0 for the function f of x plus h minus f of x over h, which will give us, simplifying, we're going to substitute the x plus h into our function. The limit as h approaches 0, f of x plus h, that is a negative x plus h squared, minus the function itself, which is a negative x squared, everything over x squared over h, which simplifies to the limit as h approaches 0. Expand here, we'll get negative of x squared plus 2xh plus h squared plus x squared when we separate the function over h. Simplifying further to limit as h approaches 0. Then multiplying by the negative here, we'll get negative x squared minus 2xh plus, that is a negative h squared again. Okay, remove that, a negative h squared, negative h squared, and then plus x squared over h. Now the x squared terms will cancel out, so we are going to get the limit as h approaches 0. We have got negative 2xh minus h squared over h. Well, this simplifies to the limit as h approaches 0. Let's put it down here over h, and which is equal to the limit as h approaches 0. Now this translates to negative 2xh over h minus h squared over h, or some will choose to factorize the h here on top, then you divide the h, cancel out the h, so that will give us the limit as h approaches 0 minus 2x minus h. Now when we simplify that further, we substitute now the 0 into that h, so get therefore our derivative from first principles being a negative 2x. Remember, I always say that you can always check with your rules for differentiation. If this, you just have to check out if f of x is equal to negative 2x. If you use the rules of differentiation, multiply the exponent by the coefficient, you get f of derivative of f of x is equal to negative 2x. So that will give you a clue of what will be your final result from your first principles. Now let us move to the next one, also to use the rules for differentiation, that is 8.2.1. 8.2.1, we are given the function f of x is equal to 4x squared minus 5x squared. That is 4x to the power 3 minus 5x squared. So we are required to find the derivative. Okay, the first derivative if it is given that. So here we have to use the rules. You can see that is 2 marks. So there isn't that much here. You just apply the rules, which is the derivative is equal to multiply 3 by 4. That will be 12x squared minus 10x. That will give us our final answer to that. Then the second one, 8.2.2, which is the derivative of x, the derivative of the function minus 6 into the cube root of x plus a 2 divided by x to the power 4. Okay, this needs to be manipulated a little bit. So prepare it so that we can differentiate. So we'll get the derivative of x. First of all, if you are given said numbers or square root sign, translate that one into exponential form. So that will give us a negative 6 by x to the power 1/3. So a cube root of x translates to x to the power 1 over 3. Okay, and then plus 2 over x to the power 4. So we are just preparing so that we put it in standard form. Then that will give us the derivative of x. Now when we simplify this one, the terms in the numerator, they are divided by x to the power 4. So we can split this one into negative 6x to the power 1/3, divide that by x to the power 4, and then plus a 2, we divided by x to the power 4. Okay, that's the reasonable thing to do here. And then we're still finding the derivative. We are simplifying that expression. So we have negative 6 x to the power 1/3 divided by x to the power 4, x to the power 4. So that will give us, so since these are separating, we use the rules of exponents. We keep the base and we subtract the exponent. So that will be 1/3 minus 4. Okay, that will give us minus 3 and 2/3. Okay, but now then you have to write that one as an improper fraction. That will give you 11. So that will be minus 11 over 3. Okay, when we simplify that part. And this one here, we need to take the it's an inverse situation here. Our x is in the denominator, so take the x up into the numerator. So we'll get it plus 2x and the x to the power negative 4. Okay, so once we have our function now in standard form, we have got exponents, we've got coefficients, then we can find the derivative. Apply the rules. That will be negative 11 over 3 by 6. That will give us positive 66 over 3, I guess. That will be x to the power negative 11 over 3. So that is negative 11 over 3. Subtract 1. We always subtract from the exponent. We'll get that is negative 14 over 3. Okay, and then we multiply here, we'll get negative 8 x to the power negative 5. So, well, we can simplify this coefficient here to give us a 22 x to the power negative 14 over 3 minus 8 x to the power negative 5. Okay, you can choose to write those exponents as well as positive exponents, but that's fine for now. Then we have got question 9 on cubic functions from the same year. So we are given a sketch of the cubic function f of x is equal to x to the power 3 plus ax squared plus bx plus c. So we are not given the complete equation for the function, so possibly we'll be asked to calculate the A and the B. So the x-intercepts of f of x are 3, 0. So we are given the x-intercept over here, which is a 3, 0. Okay. And we also given m is an x-intercept here, but it's also a turning point. Let us take note of that. So, and m lies on the negative x-axis. We can see that is on the left of the y-axis. And then k, we are given a point here, which is a y-intercept of f, and m and n are the turning points. So these are turning points. Then we are required to show that the equation of f is given by this. So in other words, we are required to prove that the equation for this cubic function will simplify to that function. So what we are given here is basically we are given an x-intercept. Okay, we are given 2 x-intercepts plus one point, one other point. So we have to use the equation for finding the cubic function. The formula that we use here will be 9.1. Let's take that number down. So we have to use the standard formula. Y is equal to a x minus r, okay, r1, and then x minus r2 squared. Now we have got a squared term here because we have m as a turning point. So if one of the intercepts is a turning point, which means that one is a repeated root. So the r2, this will be our r1. Okay, that is our r1 over here, and that will be our r2. R is simply standing for the first root and the second root. So if we are going to substitute these terms in here, we will get our y will be equal to a. Already we are given over here, it's a 1. So that will be 1 into x minus r1 is the first root, which is a 3. Okay, into x minus r2. Now we don't know the root here, so let us keep it as r2 like that. And then we are given this point k 0, 3. 0, negative 3. That means that our y is a negative 3 and our x is a 0. So these are our xy coordinates values. So we can substitute where there's an x and a y. So as a result, we'll get our y will be a negative 3, substituting it into this equation. And our x is a 0, negative 3 into x again, it's a 0. Minus, we'll keep the root r2 squared. Okay, squared over here. That simplifies to a negative 3 is equal to a negative 3r squared. Divided by negative 3, we'll get therefore our r squared is equal to a 1. Which means that to get our r, we have to find the square root of 1. It can be positive or negative, so positive or negative square root of 1, which can be positive or negative 1. So considering the fact that our r is on the negative end of our x-axis, so it means we are going to take the value 1, which means therefore that our m is going to be the point a negative 1 and a 0. So now the second step now is to find the complete equation after finding that root. So we are now going to have here our f of x or our y as we initially started here. Our y is x minus 3, that one. So we are going to substitute the value of our r there, our root for m. So we are going to have our y is equal to x minus 3 into x minus 1, which will give us x plus 1. But remember that one is a repeated root or a turning point, so we have to square. So to come down to this function here, we have to remove brackets here, expand that. We are going to get our x minus 3, keep that one, and then expand over here. We are going to get x squared plus 2x plus 1. And then we'll multiply each term into there. We will get x to the power 3 plus 2x, x there, plus x, then into that one, minus 3x squared minus 6x minus 3. Collect like terms, we'll get x to the power 3, 2x plus x, 2x, okay, this is an x squared, this is a 2x squared, was this x by that one, x squared. So a 2x by negative x, that will be a negative x squared. This x by negative x, that will be negative 5x and minus 3. Okay, which will give us the value of f. Therefore, we can say our function f of x is equal to x to the power 3 minus x squared minus 5x minus 3. Okay, so we prove that. Now then we are required to calculate the coordinates of n. So n is a turning point. So we know that's where the calculus part will come in, the differentiation part. So we know that at the stationary point, n is a stationary point, it's a turning point. So at the stationary point, 9.2, the derivative of f of x at the stationary point is equal to 0. So the derivative of f of x is 0. So we have to differentiate the function here, which is a 3x squared minus 2x minus 5. Equate that to 0. So we are from this quadratic equation, we are going to get two values of x. One will be for m. We already know it's a negative 1. Then the other one will be for n. So we are going to factorize that one to get the solutions. So that will be a 3x and then x. Okay, I always multiply these 3 by that one. I'll get a negative 6. And that will give us a negative 15 rather. Negative 15, and that will be negative 5 and negative 2 and positive 3. Okay, so I'll put divided by 3, that will be a positive 1 here, and then negative 5 over here. So multiplying that, we'll get our x equals 5 over 3, or x is equal to negative 1. So now we know that the other x value is the m value that we got here. So which means the x coordinate for n is a 5 over 3. But now here they want the coordinates of n. So we need to find the y value, the corresponding y value. So we have to substitute the x coordinate into the x value into the original equation. So we'll get here our y should be equal to f of 5 over 3, which is equal to substituting the 5 over 3 for the x value over here, which is 5 over 3 to the power 3 minus 5 over 3 squared into that. Okay, let's put that one into our calculator. So we enter that one into the calculator. We'll get negative 256 over 27. So our y value will be negative 256 over 27. It's preferable to leave it like that one, which means therefore the coordinates of n will be 5 over 3, and the y coordinate will be negative 256 over 27, which is quite reasonable. As you can see that here our n is on the negative end of the y-axis, so the negative value, well, is reasonable. Okay, then the next question, 9.3, is to find the value of x for which f of x is equal to 0, 9.3. So what are the values of x for which the function itself is less than 0? This simply means what are the values of x, what are the range of values of x where our function is negative. Where is it below the x-axis? Okay. The value of y, where are the y values below here? So you'll find that here our graph is basically negative on the rest of the part, or that part is on the negative portion. Okay, except after the value x here, then it rises up. So we can see that for all the values from 3 up to the left, our x is, our graph is negative. So now we just have to say that here our x, the values to answer that question, our x is less than 3, which means our graph is negative. But now at this turning point here, we have to exclude the turning point, because at m, our graph is not exactly negative, less than 0. It is actually 0. So we have to exclude that part. So we have to exclude that, say x is less than 3, but also we can say x is not equal to negative 1, which means it's any number less than 3, but x not being equal to negative 1. Okay, that will answer that part. And then the next question, 932, for which values of x will f be increasing? 932. This is 931. A function is increasing where it has got a positive gradient. So if I can just remove this one, you'll find that our function here is positive all the way, and is positive. Our gradient is positive, it's rising up. Okay, so the implication is that it is increasing, but when it reaches m, it starts to decrease. Our gradient becomes negative, and then after the point n, it starts to increase again, positive. So where is our graph increasing? From -1 going to the left, okay, which we can write as x less than -1. And also from n, from this value here, which we have calculated earlier, 5 over 3, from x going above, that is x greater than 5 over 3, our graph is positive. So it is increasing on that section and that section. So we give that one as our answer. Therefore, our x should be less than -1 and x is greater than 5 over 3. That's where our function is increasing. Okay, you can write these inequality expressions as, if you want, for example, to write this one in another way, you can say x is an element of numbers from -infinity up to -1. And also this one, you can write it as x element of numbers from 5 over 3 up to infinity. Okay, here you have to make use of round brackets, because the 5 over 3 and -1, they are not included. They are not included here. So that answers question 9.3.2. And then 9.3.3, we are required to find the values of x again, where f is concave up. Okay, we know that for a graph to be concave up, we have to find what is called a point of inflection. Now, a point of inflection is a point that is between the two maxima, means the value of n and n, somewhere in the middle here, where the graph changes its concavity, okay, from concave down, in this case concave down, then to concave up. So there's a point here. So now, if we are to find the values of x where f is concave up, so f will be, our function will be concave up from the x value here, okay, from the x value here on the point of inflection up to infinite. So first of all, the initial step is to find what is our point of inflection. And to find the point of inflection, we have to find the second derivative. Okay, so let us first find the point of inflection, 3. So our second derivative should be equal to 0. That will give us the x value of the point inflection. Now, we have just found our first derivative somewhere here when we derived first time, so which is negative, which is 3x squared minus 2x minus 5. So if we derive that again, that is our second derivative, that will be 6x minus 2. So we have to equate 6x minus 2 is equal to 0. So for x, so that is 6x is equal to 2, and x will be equal to 1 over 3. So that is the x value of the point of inflection. So this point here that is in the middle is a 1/3. Somewhere here there is a 1/3. So there is a 1/3 here. Okay, the value of x is 1 over 3. And then from that value, our graph, that's where it changes from concave down, and then it becomes concave up. Okay, then we have to find then that we have to express that as for our answer, what are the values of x? So we have to write our answer as x is greater than 1 over 3. So that will give us the values of x. Or you can also similarly say x set of numbers from 1 over 3 up to infinity. That's where the concavity changes. All right. And then the last part of the question is to determine the maximum vertical distance between the graphs of f and the derivative of f in the interval from -1 and x. So meaning that if we were to draw the derivative graph, or the graph or the derivative of this function, we all know that it's a quadratic. So maybe it will be concave up like that one. So what will be the distance between the value of f of x, and its derivative? So the algebraic way of expressing that one is simply to say that, okay, let's take our distance, we call it, let's call it d, okay, that is 9.4 now. Let's call it our derivative, our function, our distance to be a function of x. So basically our distance will be the difference between the function and its derivative. Okay, f of x minus the derivative function, or it can be either way, or the derivative minus the function. Then that will give us, so the difference between the functions is the distance that they are asking us in the question. So our function here is x to the power 3 minus x squared. If I still remember, we minus, what is this? 5x minus 3. So minus 5x minus 3. And then we are going to subtract the derivative of the function, which we have calculated already. The derivative of this one is 3x squared, okay, minus 2x minus 5. So that expression here is the expression for the distance between the two graphs or the two functions, which we are going to simplify to x to the power 3 minus x squared minus 5x minus 3. This one, this is a negative 1 multiplying in here with minus 3x squared, positive 2x, positive 5. Okay, collect like terms, that will give us x to the power 3, the negative x squared, negative, that will be negative 4x squared, the 5, that will be negative 3x, and that will be positive 2. So this is the expression that gives us the distance between the function f and its derivative. Now, for us to have a maximum distance, the largest distance is found where the derivative of x is equal to 0. Okay, so which means we have to derive that one, which means therefore that our derivative is 3x squared minus 8x minus 3 will be equal to 0. So we are equating the derivative of this function to 0, and we have to open up brackets again, simplify that one, that is 3x and x. Now this is 3 by negative 3, that will be a negative 9, and that will be, I need the negative 9 and a positive 1. And then the answer will be a negative 3 here, that will be a positive 1. Okay, so, well, I've explained this one in other videos, so I'm just doing it quick here so that we get to factorize the expression. So therefore, solving this one, our x will be a negative 1 over 3, or x is equal to 3. Now, we are given that there's a condition that our x should be a number between negative 1 and 0 here. So which excludes one of the values of x that we have got here, and the value that satisfies that is x is equal to negative 3. Therefore, our x will be equal to negative 1 over 3. Well, they are asking us to determine the maximum vertical distance between the graph. So now for us to get the maximum vertical distance, this x value is the value that gives us the maximum. So to find the maximum, we should go and substitute it into our function that gives us the distance. So we are basically going to take in, therefore, our maximum distance. Our maximum distance is going to be basically d of a negative 1 over 3, which we are going to substitute in here, which is a negative 1 over 3 to the power 3 minus 4 into negative 1 over 3 squared minus 3 into 1 over 3 negative plus a 2. Okay, which we will have to simplify. Let's enter that one in our calculator. Okay, the value that I'm getting here after entering is 68 over 27. 68 over 27. which we can write to a decimal as 2.518. 2.518, okay, units. Okay. So that brings us to the end of that question. See you next time. Please don't forget to subscribe and share the video. If there are any comments that you wanna put forward, please do so. See you next time. Bye.